Okay, we're continuing our notes on hydrates, and the first page we learned how to find the percent composition of each component of a hydrate. But now what we want to do is determine the formula of the hydrate from the percent composition. So this is if you have the percent composition and we're looking for the formula. We're going to use a technique very similar to what you learned in the empirical formula videos that Mr. B made. Okay. So we're going to find a ratio of the ionic compound and the water molecules. Remember the molar mass, it should say molar mass right here. Remember the molar mass of water is 18.015 grams per mole. Only use the first 3 lines of the poem because the ratio is always 1 to x. So we're going to use this number a lot. You may want to memorize it, if not just be able to quickly calculate it. We're only going to use the first 3 lines of the poem. So the poem was percent to mass, mass to mole, divide by small, multiply till whole. We're never going to multiply till whole. Okay, it's just going to be percent to mass, mass to mole, divide by the smallest, and that's when we're going to be done. We'll know what the formula of the hydrate is. Okay, and again, the formula of the hydrate, we're always looking for the coefficient for water. Okay, so a lot of times the questions will be written similar to this. Not always, but a lot of times they will. Where you've got an x in front of water. You're solving for x. How many water molecules do we have in this hydrate? So let's read the question. Hydrate of lead 2 perchlorate, PbClO4 x H2O, contains 88.25% of lead 2 perchlorate and 11.75% of water. We want to determine the formula of the hydrate. In other words, we're solving for x. There's a couple things that we're going to need. If I am going to be using these percents, so I'm turning percent to mass, so I've got percent of lead 2 perchlorate and I've got percent of water, and I want to know the ratio between these two. So I need to be able to go from percent to mass and then from mass to mole. For both of them, I need the molar masses. Molar mass of water, you may have it memorized. If not, you could calculate it pretty quickly, I think. But it's 18.015 grams per mole. We want to have our molar masses ready to go before we get started. Okay. The molar mass of PbClO4, that one we're going to have to look up. So let's find Pb. It's a metal, but it's over here towards the right. It's 207.2 plus, let's see, we've got 2 chlorines. I'm distributing throughout this 2 chlorines, so 2 times the mass of chlorine is 2 times 35.453 plus 2 times 4 gives me 8, so 8 times the mass of oxygen, which we know to be 15.999. If you haven't memorized it, that's okay, but that's what that is. And then we are going to add those up. I've already done that math for you, so the sum of that, the molar mass of lead 2 perchlorate is 406.098 grams per mole. All right, so we've got our molar masses. Now we can start the process. Okay, so it starts out by percent to mass. So we have the percent of lead 2 perchlorate. I'm just going to rewrite this, but instead of percent, I'm going to put grams. 88.25 grams of PbClO4, and we're going to multiply by a fraction. We'll get to that in a little bit. Multiply by a fraction, and we'll fill that fraction in a moment. Okay. The next thing, we have water. We have the percent of water, 11.75% of water, but we're going to call it 11.75 grams of H2O. And the reason we can do this is because we're assuming that we have 100 grams. Since no amount was given to us, we can make the assumption, since we only know percents, that we have a total of 100 grams 88.25 of the grams comes from this, 11.75 grams comes from water, just in case you were wondering why that is. All right, the next thing we're going to do is go from mass to mole. We did percent mass, now we go mass to mole. So on the bottom, we need to cancel out our units. Grams of PbClO4 I've got my molar mass here, 406.098 is the grams of PbClO4 that are in 1 mole of PbClO4. Okay, and then right here we've got water. We want to put the mass of water, 18.015. Put a comma there on accident. 015 grams of H2O for every 1 mole of H2O. All right. And we want to solve that. So the next thing that we're going to do, put an equals sign. When you divide these out, the first one is going to be 0.2173. Okay, and then when we divide the water out, we get 0.6522. So I'm going to divide by the smallest, so percent to mass, mass to mole, divide by the small. Well, the smallest one is PbClO4, which makes sense. We're going to divide by that number. We're going to divide both of them by that number. And that's going to give us the amount of PbClO4, well, that's just going to be 1 mole of PbClO4. But here, when we divide it out, we're going to get 3 moles of H2O. Which leads us to our formula. We have PbClO4 and we'll put our raised dot right there, and it's 3 H2O. And then we want to name it. That is lead 2 perchlorate, which was actually given up here, lead 2 perchlorate, but then I need to write the hydrate. So it's 3 waters, so it's trihydrate. All right, that's it for the first example. Let's do the next one. Let's do our second example problem. Hydrate of magnesium chromate. So I have MgCrO4 and I have XH2O. It contains 39.10% of water. We want to determine the formula of the hydrate. First thing we want to do is have our molar mass of water, 18.015 grams per mole. And if you don't have it memorized, just calculate it real quick. Okay, magnesium chromate. So I need to find the mass of magnesium, 24.305. Plus the mass of chromium, Cr is 51.996, plus 4 times the mass of oxygen, which is 15.999. All right, add those up and you will get 140.297. All right, so we've got our molar masses now. What we didn't have yet was the percent. We have percent of water. We don't have percent of magnesium chromate. So the way we would find that is, well, the percent of magnesium chromate plus water is going to be 100. So if we added them together, they would be 100. So I can say the percent of magnesium chromate will equal 100 minus the percent of water, which was 39.10%. And that gives us 60.90%. Now we've got our percents, and that is percent of MgCrO4. All right, percent to mass, that's where we're at right now. So 60.90 grams of MgCrO4. And we're going to multiply by a fraction with the molar mass. We have 1 mole of MgCrO4 on top, and we're going to have grams of MgCrO4 on the bottom. It's 140.297 is our molar mass that we're going to put on the bottom. And we'll solve for that in just a moment. We also need to set up the same process with water, 39.10%, so 39.10 grams of H2O times 1 mole of H2O over, in the molar mass of H2O, it's 18.015 grams H2O equals, and then we can solve for them. So again, we just did percent to mass, just wrote it as grams. We need to convert to moles. You do that by dividing by your molar mass. I should have labeled this. You want to make sure you're labeling your units. It's a good habit to be in. Okay, and then the answer you're going to get for the first part is 0.4341. The answer you get for the second part is 2.170. 2.170. We want to divide by the smallest, which of these two, 0.4341 is the smallest, so we'll divide by 0.4341 in both cases. And 0.4341 divided by 0.4341, of course, equals 1. But if I divide this by 0.4341, I get like 4.99, which is about equal, it's approximately equal to 5. So it's close enough to 5 that we can call it 5. We're going to write our formula here as MgCrO4, and then our raised dot. Probably other places to find it, but that one's an easy one to find. Raised dot, and then we have 5H2O. And the name for this, magnesium chromate pentahydrate. All right, that's it for the hydrate notes. Work through some practice problems. Let us know if you have any questions.